Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. This is question 2145, count the hidden sequences. So basically you're given this integer array called differences, and your goal is to go through lower and upper and create as a starting point all of the numbers accumulating from that point. So for example, for 1 would be 1, 2 because plus 1, and then minus 3 is minus 1, and then plus 4 is 5. So this is not fitting because the range is 1 to 6 and there are numbers that are outside of the range. So we just want to count how many prefix sums from lower to upper satisfy this range. So for 2, for example, that would be 2, 3, 0, and 4. Again, that for this one, let's see here. So for lower, we're doing 2, and so 2 plus 1 is 3, minus 3 is 0, and then plus 4 is 4. It looks like from this picture, let's take another example just so I'm on the right track here. For 3, let's say we're doing 3. Okay, so 3 and then plus 1 is 4, minus 3 is 1, plus 4 is 5. This falls within the range, which is fine. And so does starting with 4, right? So 4, 5, 2 plus 4 is 6, right? So that still falls in the range. Cool. So for 2, let's do this again. So 2, 3, 0, 4. So this doesn't fall in the range, right? Because 0 is less than 1, so this is a no-go. These are yeses. So we just want to count how many sequences are valid and return them. Okay, so hopefully that makes sense now that we have that out of the way, have some examples to work with. Let's go ahead and just do the brute force approach. Upper plus 1, so this is what I first came up with, and then I'll show you the way I found to optimize this. So basically now we're just going to create a new array with I, and then we're just going to add differences, and then we're just going to take itertools.accumulate new, because if we print each iteration, we should see all the options we have. And then again, only if minimum of p is in the range, right, lower, and max of p is less than or equal to upper, then we're going to increment our answer. Okay, so in that case, let's print p. So you can see 2 there, and then we can just return answer. So that's the count of how many valid subarrays we have. The problem here is this is n squared because this takes n and then n. So n times n is going to be too slow for larger inputs. So as I said, let me show you the way that I came up with to optimize this. So the strategy that I used was to go ahead and use a binary search. Why? Because first of all, if we print p, let's make a couple of observations. So let's just take this set, for example, this example. Let's copy here, paste right here. Comment all this out so we don't get any errors. Okay, so let's make some observations. Notice that the valid ones are these four, right? I'm just going to do this. So these are invalid because they have some number out of the range, and we do that by checking the minimum and the maximum. So why don't we run a binary search from lower to upper, because this is the control right here. This is going to be the value we're binary searching for. If for some reason the upper value or excuse me, the maximum value of any of the arrays we try is outside of the range, in this case 6 is outside of 5, then we can shrink the search space. And then if it's too small, for example, if -5 is smaller than -4, then we can shrink the search space the other way by moving the left pointer upwards to increase the overall result, right? So until we find the point that is the lowest it can go, meaning the minimum is actually lower and the maximum value is still within this range. And in the other case, when the maximum value is still exactly the maximum value is exactly upper and the lowest value is still within this range, then we're going to mark that value. So then we're going to take how many numbers are between this and this, keeping track of the high and the low count, and then that is going to be our answer. So hopefully that made sense. Let me show you how I coded it up. So instead of doing this, let's go ahead and find the boundaries. Let's call this lower and upper is, well, let's call this left and right is lower and upper. And then for the binary search, let's do one to find the lower index first. So let's say if, let's just call this cur is mid plus differences, p is list itertools dot accumulates cur. Cool. So that's going to give us this, whatever these results are here. And then if the maximum, so if we're trying to find the lower bound, if the minimum of p is exactly equal to lower and the maximum is still within the range, this is still a valid array, then we can go ahead and print p of 0. Okay. And then in any other case, if the minimum of p is less than lower, then we're going to try to increase the overall sum, otherwise decrease the overall sum. So let's go ahead and try to see what this gives us. Notice how the lower is 3, that's good. So the lower here is -3, that's good, we're on track. So now we have to do the same thing for the upper. So let's do this again. So this binary search is to find the lower boundary, the number that causes exactly the minimum number in that prefix sequence to equal the lower number. And then we're going to do the same thing for the highest boundary. So same thing, mid plus differences, list itertools dot accumulates cur. Okay, so again, if in this case, if the maximum of p is exactly upper, and the minimum, we still have to be in bounds, right, is bigger than or equal to lower, then let's also print p0, because p0 is going to be mid, which is one of these numbers that is satisfying the equation. That is the start of a satisfying sequence. So otherwise, if max of p is too big, then we're out of bounds. We're trying to decrease the overall sum, otherwise increase the overall sum. Okay, so let's run this. And you can see 3 and 4, that's going to be the boundary. That's great. And 0 to -3 has exactly 4 numbers, right? So let's call this low, and high is float -infinity, float infinity. So, and then we can actually, the way I did it is just to use a sorted list, p of 0, because that's just going to keep things ordered like a heap. And then at the end, it says here, if there are no possible sequences, return 0. So If not SL, return 0, right? There was no satisfying sequence at all. Otherwise, we're going to return SL of -1 minus SL of 0 plus 1, because if SL of -1 is going to be -3 and SL of -1 is 0 and SL of 0 is -3, there are 4 numbers in between, -3, -2, -1, 0. So 4 numbers total. That's why we're doing plus 1, because -3 minus 0 is only 3, and we want that 4th number. Okay, so let's go ahead and run this, submit it, and there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any help and solve it completely on my own. So that's it for this video. Thank you for watching, and stay tuned for more.